This is a video about stabilization of inverted pendulum. This slide shows its characteristics. Inverted pendulum have unstable zero and unstable pole in the front and has non-linearity. It includes two sensor and motor on the inverted pendulum system. This is MATLAB simulation of inverted pendulum. We can find that tracking control can be achieved by appropriate control for inverted pendulum. The system is stabilized by using two encoders and one motor. State feedback control is applied for this system. Four states are used: angle and angular velocity of the pendulum and them of the base. Stabilize the system using state feedback control. This is the rough structure of encoder. It includes light and photo detector. The rotation table has various slits. The photo detector accepts light from this way and the voltage is given as a pulse. We count pulse and obtain the angle of the encoder system. Two angles are obtained by encoder and the angular velocity is obtained using numerical differentiation. By applying state feedback control, inverted pendulum is stabilized. We compensate the motor dead zone effect by using compensation function. By compensate the dead zone effect. This is the stabilized result of the inverted pendulum. We can find the pendulum is more stable. We can find angle tracking control in this video. This is vehicle type inverted pendulum. Pendulum is stabilized despite of the disturbance.